Good morning, students. As you can see, our today's topic is friction. Okay. In our daily life, whether we walk or we ride or drive a vehicle or even holding a pen. See, now I'm holding a pen to take the class to you. So even holding a pen, one invisible force plays a crucial role, and that is friction. Friction is often, called a resistive force, oppositive force, but without it, many everyday activities would become impossible. Today, we will understand the concept of friction from a neat perspective. We will discuss the different types of friction, important formulas, and the physical meaning behind them. So, after building a strong conceptual foundation, we will also solve some previous year NEET questions to see how these concepts are applied in your exam. And by the end of the class, you will be able to approach the friction problem with much more confidence. So, shall we begin our class? Yes. So, what is this friction? Friction is a contact force. What is this contact force? Whenever two bodies are in contact, we call it as a contact force. Any force that comes into existence when the two bodies are in contact. And there are two contact forces, normal reaction and friction. Let this be a surface. I'm just considering it as a rough surface because friction is present if surfaces are rough. This is important. If the surface is smooth, for suppose in the question, if you see smooth surfaces, in that case, frictional force is zero. Small f means friction, capital F means external force. Okay. So let this be a body of mass mkg. And this block is contact with the surface. This is a surface. And this is a rough surface. Okay. So the weight of the body will be mg, which is acting downward, and the normal reaction will be upward. Now, if you see this normal reaction, it is acting on the block and it's a contact force because when the block is in contact with the surface, this normal reaction comes into existence. What is this normal reaction? It is a perpendicular force at the point of contact. At the point of contact, the perpendicular force is normal reaction. This is one contact force. Again, for suppose imagine the block is given a push. See what is capital F? As I told you, capital F means external force or applied force. What will be the direction of frictional force here? Frictional force will be in backward direction. And this will be at the contact again. Block M is in contact with the rough surface. So at this contact, there will be a force which will be in opposite direction to external force. And what is this opposing force? That is your frictional force. So frictional force, normal reaction, both are contact forces because in both of these forces, you can see the contact between two bodies. Our topic is friction, so we'll focus more on the friction. What is this friction actually? It's an opposing force because it will oppose the relative motion between the bodies or the tendency of motion. This is important. This is important. If the body is moving forward, that means this is the direction of F applied, F external force. What will be the direction of friction? It will be in backward direction because it tries to oppose the motion. Tendency of motion, that means what? The body may or may not move, but still the frictional force is present. See, in some cases, you just imagine you are pushing a block on the floor. That means you are applying the external force, but the block is not moving. Consider that scenario. You are applying the force, you are pushing the block, but the block has not yet moved. Does it mean that frictional force is absent? No. There we have frictional force, there we have static friction, and that is equal to the value of external force itself. So the body may or may not move, but still we have frictional force. So what you have to understand is frictional force is a contact force. It is an opposing force. It opposes the motion of the body If the body is moving, even if body is not moving, when there is an application of external force, frictional force is still present. And how do we calculate that frictional forces, etc., etc.? We'll see in our today's class. Are you clear with the basic idea of frictional force? Just remember it's an opposing force. This point is important. Frictional force is an opposing force. This is important. There are two categories of friction. Number one, static friction. Number two, kinetic friction. See, static, that means when the body is in rest position. That means when the body is not moving. When the body is not moving, the friction present is called static friction. So, what is the first point? There is no relative motion. Kinematic, not kinematic, kinetic, spelling error. Kinetic friction. So, in the case of kinetic friction, the body will be in motion, the body will be moving. So, there will be a relative motion. When we come to the formula, there is no specific formula for static friction important. Imagine this is a block of mass mkg. External force is applied in forward direction. So what will be the direction of frictional force? Frictional force will be in backward direction. Now imagine the body is not moving. Force is applied, but the body is not moving. Friction is present, external force is present, but the body is not moving. So under these conditions, what is this frictional force called? It is called static friction, and its a symbol is Fs. Fs means static friction. Body is in static condition. It is not moving. So for Fs, we don't have any formula. Now, I have a doubt. See, rough surfaces will apply the friction. That is fine. Is there any limit to that friction applied? Like surfaces will apply the frictional force, but how much frictional force they will apply? 100 or 1000 or 2000? How much? There will be a limit, right? So, the maximum frictional force that can be applied by the surface is called F limiting. F limiting means it's a maximum frictional force that can be applied by the surface. This F limiting has the formula. Limiting friction has the formula, but static friction doesn't have any formula. When you come to kinetic friction, yes, it is having a formula. Let this be the block. Imagine external force is in forward direction, frictional force is in backward direction, and this time we are considering that the body is moving. The body is moving forward with acceleration a meter per second square. That means the body is in motion. Now, what will be the friction? It will be a kinetic friction. Its symbol will be Fk now. So, what is the formula for this Fk? It is mu k into N. You know about N, it is normal reaction, which is equals to mg. Which is equal to its opposite force. What is this mu k? It is coefficient of kinetic friction. Mu is actually coefficient of friction. As it is mu k, this is coefficient of kinetic friction. Got my point? Ma'am, Fs has no formula. Fk has formula. F limiting has formula. Then how do we know the value of static friction? So for that, we'll see the range. For that, we have to understand the range. So if you take static friction, its value will be either less than or equal to F limiting. That means it will be equal to maximum friction, or it will be lesser than that. And it will be equal or greater than 0. So this is the range of static friction. This is very, very important when you are solving the problems. This point is very important. They will ask you to calculate the friction. Whether it is static friction or rheumatoid friction, kinetic friction, that you have to decide. So for that, you have to remember this point. Whenever external force, this is the external force, when this is less than F limiting, in that case, static friction value is equals to F external. When external force is more than F limiting, in that case, the body will move. See, External force is smaller compared to maximum frictional force. You just have to understand with a live example. Just understand with a live example. There is a block of mass mkg. This is a rough surface. Just for the sake of understanding, this is the direction of applied force. Opposite will be the direction of friction. Now I am just taking F limiting as maybe 20 newtons. So what is this F limiting? This surface is there, right? This rough surface, maximum how much friction it can apply is F limiting. So maximum how much it can oppose till 20 newtons. Now imagine the case you have applied only 10 newtons. What is the maximum friction the floor can apply? 20. That means you are trying to pull it forward with 10 newtons, but the floor is pulling it backward with 20 newtons. Frictional force is more, F limiting is more. So in this case, what happens when F is less than F limiting? The body will not move. The body will be in rest condition. So in this case, the body will not move. Do you understand this? Imagine F is equal to 25 newtons this time. Frictional force is 20, but you applied 25 newtons now. Friction is trying to hold the body with 20 newtons. What are you doing now? Okay, friction. Your force is 20, your maximum capacity is 20 newtons, right? Now I will pull the block with 25 newtons. In this case, what happens? Extra, you're applying 5 newtons. Your capacity, your applied force is more this time. So this time what happens? The floor cannot oppose now. Friction is not of use now because its maximum capacity is only 20, but you apply 25. So this time what happens? When F is more than F limiting, the body is in motion. So this time the body will move. When it will move? When the external force is more than F limiting. And whenever the body is in motion, we are not going to use Fs. We are going to use kinetic friction because as I told you in the beginning here, whenever the body is moving, what we are going to consider? We are going to consider kinetic friction. Its formula is mu k into N. The problem is with static friction, it doesn't have a formula. Then how do you find its value? First, make sure of these conditions, whether F is less than F limiting or F is more than F limiting. If F is more than F limiting, then no problem at all. The body will be moving. You can take kinetic friction formula. When F is less than F limiting, then what is the static friction value? It doesn't have any formula. Its value is nothing but external F applied only. Got my point? Like if you take this example here, F limiting was 20, F applied was 10. So in the first case, F is less than F limiting. So in this first case, if I ask you what is Fs, how much is it? It will be equal to external force only. It will be 10 newtons only. So in this condition, how much you force apply? Same will be the frictional force. But once your applied force is more than the capacity of friction, more than the limiting friction, then you have to go for kinetic friction formula. Got my point? Static friction doesn't have any formula, but how are we going to find out the value of it? Remembering these conditions. And this is very important. If you have understood, then fine. If not, see this topic of 5 minutes topic again. Okay. Now, in kinetic friction, there are two categories again, two types of kinetic friction: sliding friction, rolling friction. See, sliding or rolling, in both the cases, the body is in motion, right? That means both of them come under kinetic friction only. But why this, separation, why this segregation? Here the body will slide. Whereas in rolling friction, the body will roll. An important point, rolling friction is less than sliding friction. This is a common observation when you take your luggage bags. See, this is your luggage bag. Okay. And there will be wheels here. Will you slide it or will you roll it? Generally, you are planning a trip and you got a heavy luggage. And will you drag your, bag, or will you just, pull it, with the help of the wheels? What will you do? You'll just try to pull it with the, help of wheels, right? Why is it so? Because rolling friction is less. If friction is less, forward motion of the body will be more. Because just that is what we have seen, right? Friction is an opposing force. It will try to oppose the motion of the body. The body is trying to move forward, but that friction will try to bring it backward. So in this case, if friction is less, forward movement will be better. And as rolling friction is less, why rolling friction is less? Again, this will be a dot because the contact will be less. In the case of sliding, contact of the body is more, so friction is more. In the case of rolling, contact with the surface is less, so friction is also less. So rolling friction is less than sliding friction. That is why if you take luggage bags, instead of dragging them, just pulling them with the help of wheels, that is better because less is the friction. If friction is less, downward arrow mark means less, then the forward motion of the luggage will be easy. Forward motion increases. So I hope you are clear with this. Very important, very important. I'm telling you, this third point in static friction is very important. Static friction doesn't have any formula. Limiting friction has the formula, kinetic friction has the formula. Then how do you know the value of static friction? For that, you have to consider two cases. If F is less than F limiting, static friction is nothing but external force only. If F is more than F limiting, then use the formula of kinetic friction. Clear? So just go through these note points, what we have discussed so far. The static friction acts on a body when the body is at rest or it has a tendency of relative motion. And what is the maximum value of static friction? That's nothing but limiting friction. What is the formula of F limiting? That is mu S into N. Fk is mu k into N. Fs is mu S into N. And what is this mu S? Mu is actually coefficient of friction. Mu S means this is coefficient of static friction. Okay. And what is the range of the static friction? Static friction will be less than or equal to F limiting or more than or equal to 0. And this static friction, it's a self-adjustable force. Why? Because within this range, when F is less than F limiting, value of static friction is equals to external force. If F is 2 newtons, Fs is also 2. If F is 5 newtons, Fs is also 5 newtons. But how long? Under this condition, if F is less than F limiting, then static friction is a self-adjustable force. And as I told you earlier, there is no formula for static friction. So clear with this? Now I am going to solve some PYQs from your NEET papers. But before going for these problems, a sincere request from my end, just revise the concept once, okay? And then come for problem solving. So see this question. Which one of the following statements is incorrect? Rolling friction is smaller than sliding friction. This is true. Limiting value of static friction is directly proportional to normal reaction. Yes, because what is F limiting? That is mu S into N. That means F limiting is directly proportional to N. So this is a correct statement. Frictional force opposes the relative motion. Yes, that is what the definition. Coefficient of sliding friction has dimensions of length. Let's see this. Coefficient of sliding friction. Where do we get this in F limiting? F limiting is mu S into N. Take the subject of coefficient of static friction. What will you get? Limiting friction upon normal reaction. See, frictional force, in the sense it's a force. What is its unit? Newtons. Normal reaction is also a force. That means what is its unit? Newton. That means you take any coefficient of friction, not only sliding, not only kinetic, or sliding friction, right? Just give me a second. I did a mistake here. 1 second. It is not F limiting. In a hurry, I did mistake. See, sliding friction, in the sense the body is in motion, right? So it's not F limiting. It is kinetic friction. Mu k. Okay, not mu s. I'm so sorry. So you take any coefficient of friction, let it be kinetic friction or let it be coefficient of static friction. It is always the ratio of frictional force to normal reaction. That means it's a ratio of same physical quantities. So they will have same units. So after cancellation, there is no unit at all. So it is basically a dimensionless quantity. Coefficient of friction is a dimensionless quantity, not only kinetic, also limiting friction. Coefficient of kinetic friction, coefficient of limiting friction, you take any coefficient of friction, it is dimensionless quantity. But the question says it is having dimensions of length. So this is a wrong statement. So incorrect statement is option D. See this question. A block A of mass m1 rests on the horizontal table. Let this be the table. There is a block A. Its mass is m1. Mass is m1. This is block A. A light string connected to it passes over a frictionless pulley. So there is a pulley and string is connected to it, passing over this pulley at the edge of the table. Anyhow, we have connected at edge only. And from its other end, another block B of mass M2 is suspended. So from the other end of the string, there is another block B whose mass is M2. The coefficient of kinetic friction between the block and the table. So between the block and the table, so this is the table, okay. Between the block and the table, there is a contact. So there is a frictional force. And what is the coefficient of kinetic friction? That is mu k. When the block A is sliding on the table, the tension in the string. So tension will be away from the block, away from the block. You have to find out this tension value when the block A is sliding on the table. Why the block A will slide first of all? You have to find tension, fine. But why will the block A slide? Have you understood the question? There are two blocks. One block is on the table, the other block is hanging. You have to find the tension. See, this is hanging. That means its weight will be in downward direction, M2G. That means the block B is accelerating downward with A. With the same acceleration as they are connected, block A will slide with the same A meter per second square. Just recollect, we have done these kind of problems before. We have seen motion of connected bodies. It's the same thing here, but additionally we have frictional force. Concept is same, but we also have to consider frictional force here. So B is moving down because of its weight. And because of the connectivity, A block is sliding forward with the same acceleration. Okay. You have to find the tension. How do we find the tension? Just apply F net is equals to MA for B block. What will you get? F net M2G minus tension is equals to M2A. We are applying for block B. So what will be the tension now? It will be M2G minus M2A. Do you find any connection with apparent weight? When the motion of the body is downward, what is the tension? What is the normal reaction? It's weight minus some additional weight. M2, mg minus ma. Yes or no? Just learn the concepts with connectivity. Okay. It will save your time instead of taking F net is equals to ma, doing all this panda. The motion of the block is downward. So what will be the tension? It will be, lighter weight. That means M2G minus M2A. What is this A now? You know the value of M2. I mean, you know M2, you know G. You just have to find out this acceleration value. So how do we find this acceleration value? Acceleration is what? It's nothing but F net upon M net. What is F net here? One force is this, which is moving the blocks downward. The other force is a frictional force. The other force is a frictional force. See, frictional force is a second force which is pulling them backward. So what is F net now? It is M2G minus frictional force. M net is what? M1 plus M2. Clear? How do you find the frictional force? How do we find this frictional force? See the diagram. Frictional force is what? Friction is nothing but, here the body is in motion, so it's a kinetic friction. So it is mu k into n. And what is n here? This is a normal reaction. So this is equal to its opposite force. That means m1 into g. So mu k into m1 into g. So just substitute that value here. m2g minus mu k into m1 into g upon m1 plus m2. Clear? Just substitute this acceleration in this equation 1. Let this be equation 1. Just put this value in equation 1. You will get the tension. Just a simplification. That's it. So tension is equals to m2g minus m2a. And what is that a? m2g minus mu k into m1g upon m1 plus m2. Now just simplify this mathematically. What will you get? This is the first term and this is the second term. What is common in both the cases? M2 is common. So take it out. G minus and multiply this minus with the inside terms. You'll get minus M2G plus mu k into M1 into G upon M1 plus M2. Now simplify for the denominator. So M2 into M1G plus M2G minus M2G plus m1 into mu k into g. Now whole divided by m1 plus m2. What gets cancelled here? Plus m2g minus m2g cancel. You will get m2 into m1g plus m1g into mu k divided by m1 plus m2. So what is common? Just take them out. Already we have m2 out. Now inside m1 is common, g is also common. So you will be left with 1 plus mu k upon m1 plus m2. So this is the answer. m1 m2 g into 1 plus mu k divided by m1 plus m2. m1 m2 1 plus mu k. So answer is first option. So how did we do this problem? It looks lengthy, but it is actually quite easy. Block B moves down because of its weight. Frictional force is acting in opposite direction. So what is the net force? You know, right? m2g minus f. So find out the acceleration. Just substitute that value in the tension equation. And how do you find the tension? Already we have done lot of problems related to this motion of connected bodies. Just take the free body diagram, write the equations and just simplify it. Okay. See, this is what, important in physics. If you want the next topics, you have to be clear with the previous topics. If you don't know how to do the problems with motion of connected bodies, then this will not be, easy for you. If you are very thorough with the previous topics, present topics will be easy. Okay. A system consists of three masses, m1, m2 and m3, connected by a string passing over a pulley P as shown in the figure 5. The mass m1 hangs freely as you can see here. m2, m3 are on the rough horizontal table. That means frictional force is present. And that coefficient is mu. Pulley is frictionless and of negligible mass. Downward acceleration of mass m1. See, we have to find the downward acceleration. See, this is moving down. What is that acceleration is a question mark. And to make it easy, it was given in the question, all these are identical masses. M1 is also M, M2 is also M, M3 is also M. So how shall we do this? What is acceleration formula? It is F net upon M net, right? What is F net here? M1 is moving down. M1, M2, M3, I don't call it as M1, M2, M3, now simply M, M, M. So M1 is moving down, so that is mg. This force is mg. Now frictional force will be opposing the motion, relative motion. So this is the frictional force and this is another frictional force. What is frictional force formula? Kinetic friction mu k into n. So this is n, this is n. Its weight downward m2 into g, that means mg, m3 into g, that means mg. So what is frictional frictional force here? Mu into m into g, and this value is same for both m2 and m3 because they are identical and they are also on the same surface. So it will be minus mu into m into g minus mu into m into g divided by m1 plus m2 plus m3. So mg is common, take it out. Then you'll get 1 minus mu. So it will be minus 2 mu by this is 3m. M cancel. Cancel, sorry. So what you will be left with? You will be left with g upon 3 into 1 minus 2 into mu. So option C is your answer. Clear? Just practice. Okay. Now, a conveyor belt is moving at a constant speed. Let this be the conveyor belt. It is moving forward with the speed v is equals to 2 meter per second. A box is gently dropped on it. So this is the box dropped on it. Then what happens to the box? Box will also move with the same speed, right? So what will be the speed of the block now? That is also 2 meter per second because it is on the belt now. So when the box is dropped on the belt, there is a contact. That means frictional force is present. So what will be the direction of frictional force on the block now? Opposite direction. And the coefficient is given as 0.5. The coefficient of friction between them, how much is it? 0.5. The distance that the box will move relative to belt before coming to rest. See what they are asking? They are asking to find the stopping distance. Before coming to rest, how much is the distance moved? What is that called? Stopping distance. What is stopping distance formula? This is u square by 2a, right? What is the initial velocity of the box get? That's nothing but the speed of the conveyor belt. What will be the final speed? 0. What is the acceleration of the block? It is nothing but F net upon m net. So there is no external force. So we have only frictional force and the mass of the block. What is frictional force? Mu into n by m. So what is n here? M into g. Let m be the mass of the box. Normal reaction will be upward and this will be equal to m into g because the weight of the block will be acting downward. N is actually equal to opposite force, right? Opposite force is weight here upon m. So m cancel. What will you get? Mu into g. So this is for the first time. So I have simplified the complete formula. A is equals to F net by m net. Next time onwards, you just have to do the same procedure. Frictional force is mu into n is equals to opposite force. Here opposite force is weight. So n is equals to m into g, cancel. You will be left with mu into g. So answer is easy now. So what is the stopping distance? U square. That means 2 into 2 upon 2 into acceleration. How much is the acceleration? Mu into g. Just substitute. What will you get? Mu value. Our mu value is given as 0.5. G is 10. So you'll be getting 5 meter per second square. So 2 cancel. 2 by 5. That means 0.4 meters. So the block will move a distance of 0.4 meters on the belt before coming to rest. The block is, the box is dropped on the belt. So belt speed is nothing but the speed of the box. But as there is a friction, this friction will oppose the relative motion, right? So it will try to stop the motion of the box. So the box will stop after moving how much distance? 0.4 meters. Clear? Fine. Ma'am, I don't remember the formula of the stopping distance. Then how? Then use the kinematics equation. V square minus U square is equals to 2AS. So final velocity of the box 0, initial velocity 2, acceleration of the block. It's because of the frictional force, right? Frictional force is in backward direction. So acceleration is also in backward direction. So it will be -5 into s. So in this way also you can do. However, you got that s is equals to u square by 2a using this equation only. If you don't remember, then you can use the direct form of the kinematics equation. A block of mass m is in contact with the cart C. Okay. The coefficient of static friction between the block and the cart. See, this is the block. So contact is there. So what is the coefficient of friction? Mu. The acceleration alpha of the cart that will prevent the block from falling. See the diagram first. The block is like this. This is the block. Okay. And here is the contact. So this block M should not fall. We have to prevent it from falling. In that scenario, what is the acceleration? Acceleration A, that is alpha, according to the question. This is the question mark. See, block will fall down because of its weight mg. There is a contact, so it will not fall because of the frictional force acting upward, right? And this is a kinetic friction, which is equals to mu into n. And what is n this time? This is very important. See, in the previous problems, the block was horizontal. So you took normal reaction equal to opposite force, and that opposite force was mg, weight of the block itself. But here this time, the block is vertical, it's not horizontal. So what is the normal reaction? See, this is the normal reaction acting on the block. So what is the opposite force here? The block is moving, the cart is moving forward. This is a non-inertial frame of reference. So what do we do in the opposite direction? We consider a pseudo force, which is equals to mass into acceleration, that is m alpha. So now this normal reaction is actually equal to what? This is actually equal to pseudo force. See, that is why concepts are important. All the time normal reaction is not equal to mg. Normal reaction is equals to the opposite force which is present. Okay. So the block should not fall. That means the frictional force must balance the weight of the block. It should be equal to or more than mg. And what is this frictional force? Mu into n. N is nothing but pseudo force, and that pseudo force is m into alpha. So greater than or equal to mg, cancel. So alpha must be greater than or equal to what? G upon mu. So what is the answer? Answer is option C. A block B is pushed momentarily along a horizontal surface with the initial velocity v. If mu is the coefficient of sliding friction, that means the block is in motion. Between B and the surface, the block B will come to rest after a time. So this time, the initial velocity of the block is v. It has to come to rest. That means its final velocity must be equal to 0. And this will happen in how much time? That is the question. So just use the kinematic equation. V is equals to u plus at. Final velocity 0. Initial velocity v. What is the acceleration? Acceleration is nothing but F net upon m. There is no external force. That means we have only the frictional force. So this is F upon m. What is frictional force? Mu into n. This is the n. And what is the opposite force? M into g. So n is m into g. So mu into m into g upon m cancel. How much you'll get? Mu into g. So just substitute here. And this acceleration is in which direction? It is in opposite direction because the acceleration is due to frictional force. So it will be minus mu into g into t. So you'll get v is equals to mu g into t. And what is t now? It is v upon mu into g. So option D is the answer. Clear? Let us see one more question. The coefficient of static friction us between block A. Okay, see the diagram. Two blocks. One is hanging, the other is on the table. A block mass is 2 kg. This is on the table. Coefficient of friction mu is 0.2. This is mu. What would be the maximum mass of the block B? You have to find the mass of block B. This is the question mark. So that the two blocks do not move. Two blocks do not move. So when they will not move, first understand the scenario. Block D is hanging. So its weight will be downward, M into G. And it is suspended with the rope. So tension will be in the upward direction, away from the mass tension. So when block B moves down because of the weight, this is the direction of acceleration. Now with the same acceleration, A block will move forward. So frictional force will be in opposite direction. This is equals to mu into N. This is equals to mu into M into G. Why is it so? Because N is in upward. Opposite force is M into G. What is this M now? The normal reaction. This is acting on block A. So mu value is 0.2. So you have to take A block mass. This is 2 into G value 10. Because frictional force is acting on A block, right? So take the mass of A block. So what will you get? Decimal and 10 cancel, 2 into 2, 4. So frictional force is 4 newtons. Did you understand this? Any difficulty so far? Now, now let's get back to the condition. The two blocks are not moving. Two blocks are not moving. So what is the condition for not moving? The downward force on block B, that is mg, should be equal to the frictional force on block A. See, friction, if the two opposite forces are equal, then the blocks will not move. This is the condition for not moving, right? So mass of block B, we don't know, G value 10. What is the friction on block A? It was 4. So what is the mass of B block now? 4 upon 10. This is 0.4 kg. So option D is the answer. Clear? Just go through the question once, what we have done, try to understand it. You just have to understand the concepts, that's it. Clear? Now we'll move on to next question. A block of mass 10 kg placed on a rough horizontal surface, that means friction is present, having the coefficient of friction 0.5. If a horizontal force of 100 newtons act on it, then the acceleration of the block. So let this be the rough surface. There is a block whose mass is 10 kg. Horizontal force is applied, let it be in forward direction. I'm just assuming this is the applied force. So what will be the frictional force? It will be in opposite direction. And how much will it be? It will be mu into N. So this is the N and this is the downward weight M into G, which is equals to 10 into G. So just substitute it here. How much will be the frictional force? Frictional force is equals to mu, which is 0.5. N is nothing but M into G. So 10 into G, G value 10. So decimal and 10 will cancel. You will get 50 newtons. So frictional force is 50 newtons and external force is 100 newtons. That means external force is more than the frictional force. Yes or no? Frictional force is 50, but external force is 100. That means the body will move. The body will be in motion now. So what is the acceleration? It is F net upon M net. So F net is external force 100 minus frictional force 50 divided by mass of the block, which is 10 again. So 50 by 10, you'll get 5 meter per second square. Clear? 5 meter per second square. So option B is the answer. Fine. See the next question. On the horizontal surface of a truck, a block of mass 1 kg is placed. Let this be the horizontal surface. A block is kept on it whose mass is 1 kg. Coefficient of friction is given. That means this is a rough surface which is 0.6 here. Truck is moving with acceleration. See, truck is moving with acceleration how much? 5 meter per second square. Then the frictional force on the block. So frictional force will be in opposite direction. How much is that? That is the question. Now, truck is moving forward with acceleration, right? That means first of all, find out the external force. How much is that? M into A. Mass is 1 kg. Acceleration is 5. That means external force acting on the block. Applied force acting on the block is how much? 5 newtons. And find out F limiting now. What is F limiting? Mu s into N. Mu s is 0.6. N is nothing but M into G. So 1 into G value is 10. How much will you get? You'll get 6 newtons. That means applied force is 5 newtons. But the frictional force provided by the surface of the truck is 6 newtons. See, this is the block. External force is 5 newtons. But the maximum friction, F limiting is how much? 6 newtons. Will the block move now? It will not move. Why is it so? Because F is less than F limiting. Now, in this case, what will be the frictional force when F is less than F limiting? It is static friction and its value is equals to external force only. That means this is equals to 5 newtons only. Ma'am, they are asking frictional force. Why do you take external force? Because that is a condition I told you, right? Here, most of the students will do mistake. Ma'am, took the formula wrong. Frictional force is mu s into n, mu into n. That should be 6 newtons, and that option is also given. But why did you take 5 newtons? Because the body is not moving. When the body is not moving, when F is less than F limiting, what is the value of friction? It's a static friction and it's a self-adjusting force. In this condition, when F less than F limiting, static friction is equals to external force itself. That is why it is 5 newtons. Okay. Consider a car moving along a straight horizontal road with a speed of 72 kilometers per second. So, car is moving forward with a speed 72 kilometers per hour. This is not the SI unit, so just convert it. 1 kilometer per hour is 5 by 18 meter per second. So 18 ones, 18 fours, and 4 fives are 20. So this is 20 meter per second. If the coefficient of static friction between the tires and the road, see this is a road. So what is the coefficient of friction at this contact between the tires and the road? So coefficient of friction is 0.5. The shortest distance in which the car can be stopped. That means they are asking again what? Stopping distance. What is the stopping distance formula? U square by 2a. What is the initial velocity? 20. But do we know the acceleration? No. So first find out the acceleration. What is the acceleration? F net upon m net. What is F net here? There is no forward force given. See, the only force that we have is now frictional force in backward direction. And what is that frictional force? Mu into n. All the time we have to do this. So frictional force is mu into n. So mu into m into g. So mu mg upon m. M cancel, you'll get mu into g. Why n is equals to mg here? Because it is, in horizontal position. Normal reaction is upward. This is the normal reaction at the point of contact, and weight of the car will be acting downward. So just substitute now. Stopping distance is equals to u square 20 into 20. This is the speed. By 2 into acceleration is mu into g. Mu is 0.5 and g value is 10. Actually, you have to remember this A will be equal to mu g. You should not waste your time by simplification. So decimal and 10 cancel and you will get 400 upon 5 into 2. This is 10. So 0, 0 cancel. You will get 40 meters. Answer is option B. One more question. Calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. So let this be the car. It is moving forward with a meter per second square. There is a body on the floor of the car, and this body has to remain stationary. See, if the car is moving, this body also will be moving along with the car, right? With some F external force. If car is moving with F external, this body inside the car is also moving with F external. But they are saying that it should remain stationary. How is that possible? With this floor, there is a contact. So in opposite direction, we have frictional force. If this F external is equals to frictional force, then this object will remain stationary, right? Because if frictional force is less, it will move forward. If external, force is less, it will move backward. But when these two are balanced, the body will remain stationary. So this is a condition. Body remains stationary. That is a condition. So we got this condition. The coefficient of static friction between the body and the floor is 0.15. So mu value is given. This is 0.15. And now we have to calculate acceleration. Condition is very clear. The body has to remain stationary. That means F external should be equal to frictional force. So you just have to find A. What is F external? F external is M into A. Frictional force is what? Mu into N. So M, acceleration we don't know. Mu value is 0.15. What is N? M into G. G value is 10. M cancel. So what is A now? 0.15 into 10. So 1 decimal, 110 cancel. You will get 1.5 meter per second square. So acceleration is 1.5. And what is the answer? Option B is the answer. Last two topics are there. Maximum fraction of the length of the chain that can hang and the angle of contact. These two topics are left. We will discuss them and then we will wind up the class. Okay. So what is this maximum fraction of the length of the chain that can hang on one edge of the table? Read the title once. Let this be the table. Let this be the chain kept on the table. Due to the weight of the chain, some portion of the chain will hang. Let the total length of the chain, let it be L. And for this L meters, let the mass be m kg. What about for 1 meter? It will be m by L. If L meters mass is m kg, what about 1 meter mass? M by L. Now let us assume that x meters is hanging. So remaining L minus x is on the table. Now for this x meters, what will be the weight for this x meters? What will be the weight acting downward? M into G. For x meters, it is x into m by L. This is the mass into G. So if this is moving down due to its weight, there will be frictional force which will be opposing this. That is why it is hanging. See, read the heading. Maximum fraction of the chain that can hang on one edge. That means it is not completely falling down. It is hanging because frictional force is balancing the weight of the hanging part. And what is that frictional force? It is mu into N. N is M into G. What is M here? You are not going to take the total chain mass. You are going to take the mass of this L minus X part. For 1 meter, it is M by L. You can see for 1 meter, what is the mass? M by L. For L minus X meters, it is L minus X into M by L. So, M into G. So, this is the final expression. Now, what we have to do is, as it is hanging, for hanging, that means for not to fall, what is the condition? This weight of the hanging part must be balanced by the frictional force hanging on the remaining part. So if you simplify this, you have to simplify this. If you simplify, we'll get fraction of the hanging length, which is equals to mu by 1 plus mu. What will be the fraction of the length of the chain that will be hanging? It will be mu by 1 plus mu. You have to remember this. Remember this formula. We'll see one question on that. A heavy uniform chain lies on the horizontal tabletop. Fine. If the coefficient of friction between the chain and the table, what is the coefficient of friction? 0.25. Then the maximum fraction of the length that can hang over. That means they are asking fraction. See, x is the length of the chain that is hanging. L is the total length of the chain, but they are asking fraction of the hanging part. That means x by L. If they ask you what is a fraction of the chain on the table, then what will you do? L minus x by L. Be very clear with the concept. X is the hanging length, L is the total length. They are asking fraction of the length that is hanging. So x by L. So what is this value? Mu upon 1 plus mu. So this is 0.25. 1 plus 0.25 is 1.25. Decimal cancel. So 5 is, why with 5? You can go directly with 25 table. So 25 ones, 25 fives. So 1 by 5 is how much percentage? 20 percentage. Option A. Option A is the answer. Last topic for today's class, contact angle, contact force and the angle of friction. So what is this angle of friction? See the diagram, it's very easy. See, consider a block. This is the block, okay, of mass m kg. We are applying the force in forward direction. So what will be the direction of friction? It will be in opposite direction. And you can see it was mentioned limiting friction. That means the block is not moving. It is ready to move, but it was not moving. Force is applied. The body is ready to move, but it was not moving. Under that condition, the weight of the block mg downward, normal reaction on the block upward, and this normal reaction is nothing but mg again. And what is this F limiting? F limiting is nothing but mu into n, so mu into mg. Now we have two forces here, normal reaction in upward direction, limiting friction in left direction. So there is a resultant between these two. So if you take the resultant, it is making some angle with the normal reaction. What is this angle? This is your angle of friction. So what is angle of friction basically? It is the angle between the normal reaction and the resultant of normal and limiting friction. So how do you find this angle now? Just apply the trigonometric function tan theta, opposite by adjacent. So what is this opposite side? It's nothing but F limiting. What is the adjacent side? Normal reaction. F limiting is mu into n by n, inverse into n. So n cancel. What are you getting? You are getting mu s. So what is the tan of angle of friction? This is equals to mu into s. Very important. So tan of angle of friction is nothing but the coefficient of static friction. No need to find normal, limiting friction, then taking the resultant. Don't do this vector cases and all. Simply what it is just equal to coefficient of static friction. Clear? So angle of friction, it's an angular gap between normal reaction and resultant. And how do you find that? Tan theta is equals to mu into s, where theta is the angle of friction. So this is what for today. I hope you have understood today's class. In the next class, we'll discuss motion of a body in inclined plane. We'll discuss the concepts related to inclined plane, smooth inclined plane, rough inclined plane, and how to deal with problems and all. So that we will discuss in the next class. So we'll just quickly summarize what we have discussed today. We learned that friction is not just a force that opposes the motion. It is a force that makes many everyday activities possible, like walking, writing, holding the objects. Of course, it opposes the motion. Of course, it wastes some of our energy, but still it is required for some daily activities. And we have also seen the different types of friction: limiting friction, static friction, kinetic friction, and also we have seen the role of the coefficient of friction and how this friction behaves in different situations. And as every time we do, apart from the concept, we also discuss the NEET PYQs, and they are very easy. They can very easily, solve when your basic concepts are clear. When your basic concepts and free body diagrams are clear, friction problems are very easy. Okay. So just remember one thing, keep practicing more and more problems. Then you will find friction is very easy topic. Okay. So thank you so much and all the best for your preparation.